Hello, everyone. My name is Caspar van Leeuwen. I'm an HPC advisor at SURF, and I'm very happy to be here today, at least virtually, because that was the only way I could join today. But I would like to first thank the organizers for organizing this session, which in my view is very important, and for inviting me here to talk to you a little bit about how we do software testing within a project I'm involved in, which is the EESSI project. And in this presentation, I will first start with a short explanation what the EESSI project is, and then highlight how we do software testing there. All right. So the EESSI project has the following scope and goals. So EESSI stands for the European Environment for Scientific Software Installations, and we aim to set up a shared repository of optimized scientific software installations. What does that mean? Well, as you probably know, a lot of HPC sites nowadays provide software stacks to their end users, and they will do these installations themselves. They will optimize these installations for their users. And that is, of course, a lot of effort. And that means that also a lot of duplicate work is being done across HPC centers. From the user perspective, if you move from one HPC cluster to another, or maybe from your local university to a central HPC cluster, you have a lot of differences in software environment, which is also difficult. So the idea in this project is, what if we can come up with one centralized set of installations, one software stack that we can offer on multiple systems. That will make it easier on the user because they don't have all of these differences between different systems, and it would make it easier for HPC sites since they can share the workload. But of course, we're still aiming at HPC, so performance and software testing are still two very important components in this project. And to give a little bit of an idea about why performance is so important when you're considering software installations, suppose that we look at GROMACS, and this is a pretty typical example for a scientific software installation that is used a lot on various HPC systems. And what you see here in the graph below is that if you just do some generic installation that is optimized for a generic instruction set, the performance that you get can be a lot lower than when you properly optimize for the hardware that you have available. So in that sense, the way that you do this installation is very, very important, and it needs to match with what your system supports. And that, of course, is also a challenge in a project like EESSI. Like, how do you do a software installation? How can you offer a single centralized software stack if it needs to be used on many different systems? The way we tackle that challenge is that we actually do multiple installations with various optimization options and select the correct optimization at runtime. But to give a little bit of an idea of what the EESSI project looks like, the colored components are essentially the components within the EESSI project. So in order to offer a centralized set of software installations, of course, you need some way to distribute that. So that is our file system layer. We use the CERN VM file system for that, which is essentially designed for this type of use case. So it's a very natural choice. Then there is a compatibility layer on top of that, which essentially is a Linux installation, Gentoo Linux, and we use this because you can install it in a custom prefix, and essentially it provides an isolation from the host OS in a similar way that the OS in a container would do, right? So it's a similar type of isolation. And then on top of that, we install the actual end user software that we're interested in offering. So that's the software layer. And that's where we also focus a lot on optimizing those applications for various instruction sets, for various architectures, etc. And of course, across all of those components, you need to do proper testing to make sure that this works well. So that's where we use the reframe software to write and run tests. And as you can see, all of this runs on top of a host operating system, but of course we try to isolate from that as much as we can, while still being able to use things that are specific to that machine, such as GPUs, etc. So what does that look like from a networking perspective? As I said, we offer a centralized software stack So that means there's one central point that defines what is in the software stack. That's called the stratum 0 in CERN virtual machine file system terms. That's in the center here of this image. Around it, you see the stratum 1s. Those essentially hold a full copy of the software stack. And then there are various caching layers until you, in the end, reach the end user client. And of course, the end user client can be on an end user's laptop, but it could also be on an HPC cluster or even a cloud virtual machine. So the idea is that it should be very easy to use this software stack. So, and it is essentially you can do this in 3 simple steps. You have to have the CERN VMFS installed, or use a container that has the CERN VMFS installed in it. Then there's an initialization script that you source, which basically sets up the environment. And as soon as you've done that, you basically have all of the modules in this software stack available. So you can do all of the regular module load commands that are typical on an HPC system, load a module and run your scientific application. Of course, if we offer one centralized software stack, that means that we're targeting a lot of end users, right? This could be thousands or tens of thousands of end users. And that means that software testing is even more important than it already is for an individual HPC site. So just providing the installation is not enough. We need to really make sure that this works correctly. And if we look at software testing, there's actually a couple of different purposes that we can distinguish. There are smoke tests where we really try to find major problems, right? Something that is really completely broken. I don't know, binaries that are completely missing or stuff like that. Then there's functional testing. So does my software actually produce the result that I expect it to produce? Performance testing, does it produce that result within the expected time? There's integration testing, which again is specifically important for the EESSI project. How does it work on my system, right? It needs to work on a lot of different systems. So it's very important to also test this aspect. And finally, there's monitoring. So if we change a little component, if we update some piece of software, don't we break anything else? And currently in all of these, for all of these purposes, we're actually using Reframe as a software testing framework. What is also very important, that is, of course, also the main topic of today, is the portability of tests. If we want this software environment to be available on any system in the world, we will also want to be able to test this system on any, or test this software environment on any system in the world. And that means it should be portable, but it should also be easy for the end user to test. I mean, if we're talking about the end user on their local laptop, this could be a researcher with limited technical knowledge. And ideally, you just want it to be a flick of a button in order to run the software test suite. In order to get this portability, of course, the test logic should be decoupled as much as possible from the system-specific details, and then the system-specific details should be in one place and easy to define for the person who wants to run the test suite. Now, this is, of course, a major challenge in general, right? But I think our project, we've been talking a lot with the Reframe developers, and I think it's been a very nice collaboration in order to try and get more features in Reframe that make this portability even better. Like, they were already down that road, but now with a concrete use case, it was actually easier to get some features implemented there. So that was a very nice, nice collaboration in this context. But that's not the only collaboration that we get because of the software testing we want to do in this project. Another nice goal is to get better collaboration with application experts, because of course, if we service a large amount of end users, it also becomes more relevant for application experts that our software test suite is actually a good one. And who better to know this than the application experts themselves, the application developers, for example. And I think this goes in general for, this applies in general for portable test suites. The better portable it is, the more potential end users you have, and the more it's worth it for application experts and developers to invest time in helping you set up a proper test suite. So I think that that's a nice side effect of having this in a centralized, having organized this in a centralized way. And finally, what is the current status of EESSI? So of course, we have a lot of plans, but where are we today? Well, we have these smoke tests. They're pretty much the easiest ones, right? We have those in place. We have some functional testing for the software layer, but that's still a work in progress. So what we mainly focus on now is a very limited set of applications and trying to design those tests in a way that is as portable as possible, and trying to run that on a lot of different systems and see how that works, what kind of challenges we face. And I think for the functional testing part, we actually have most of that under control now. We kind of have a handle on that. But for the performance testing, that is still a very difficult scenario, because what is the expected performance of a system that you don't know at the time that you're developing the test suite? That is a very difficult problem to solve. So I think that's still an outstanding issue that we would like to really have suggestions on, if people have suggestions there. And with that, I would like to finalize with some references. So if you're interested to know more about EESSI, these are some of the places you can have a look. And I would like to thank you all for your attention.